And we have simultaneous translation. We have our team of interpreters over
Good
here.
morning, Ivano. How
Good
are
morning.
you?
Hola, mis amigos. Bon dias. That's all I
Buenos
can
días.
speak. That's all I can speak in Spanish, despite having relatives in Buenos Aires, Argentina, and visited Santiago, Chile once, and Montevideo, Uruguay once. I love South America, and thank you for having me speak today. It's a pleasure for me to come speak to you. I would like to visit you, but to come speak to you about our experiences in smart grid here in Canada. I am sharing a screen with you. Hopefully, everyone can see it. Um,
Perfecto, yes.
yes, very good. Um, it's exciting to speak internationally. I've done some international work, and I'm always excited to be in front of people to share our experiences. We're an industry in Canada and even globally with the energy sector that we love to share our experiences and let people know what we've learned and the mistakes we've made and the successes we've had. And so I'm very proud to do that on behalf of uh, Canada in terms of our participation here, but also as our particular utility here in Oshawa. Oshawa is a distribution company, and we are located about 20 minutes outside of Toronto, Toronto, the largest city in Canada. We have a roughly 65,000 customers. The size of our load is roughly 250 megawatts, and we service an area roughly 30, 40 square kilometers in the city. It's an urban center that's growing. Oshawa is one of the top 5 largest growing cities in Canada as of today. And we are definitely more than just a distribution company. We actually have 3 companies I look after. One is the utility, which we'll talk about today and where Smart Grid plays. The second is we own a generation company, lots of renewable generation in southern Ontario, solar, wind, combined heat and power, and an anaerobic digester that we've just built and launched in the Toronto Zoo. And so that energy company is generation and providing services, and we do that not only in Oshawa but outside of Oshawa as well. And the last company we own and operate is called Durham Broadband, providing high-speed internet. And this is core to our strategy in energy and data, both the generation of energy in distributed form, as well as the distribution of energy in connected form, in combination with telecom services, which is an enabler of data. Energy and data is our future, and that's our strategy in terms of the company. But today I want to talk to you about our smart grid experiences and share that with you. We've done some excellent work here in Ontario, but we're not perfect. We've learned a lot of lessons. So when you talk about smart grid, you really want to talk about defining what smart grid is. And again, I talked about our core strategy of how smart grids really are an integration of communications, data, and energy. It's how we use the energy, when it's available, where it's available, the price point, and the like of in order to move electrons efficiently and effectively, cost effectively for our customers. We basically need the information, and time stamped information is critical. Um, One thing I've learned across the world is no matter which jurisdiction you go and visit, the cost of energy is something people are generally having issues with in terms of affordability. Even here in Ontario, we have lots of resources in Canada, but one of the things that's critical, and our last government was deposed in the last election because of the energy issue, the affordability of energy. So we actually had a change in government as a result of energy being one of the prime issues for our voters. So even in a very world like ours, where we have lots of resources, supply of generation is available. We like to produce our own supply. We don't import, we export our oversupply of energy. Even the cost of electricity, the cost of energy was a critical factor to people. And that's important because society sees energy as a necessity of life. It's up there with water, and it's up there with clean air and the likes of of what people need to survive. And so when you're talking about energy, you need to communicate price and the use of energy, which is critical. That's critically important when we talk about smart meters. But when we talk about smart grid here in Canada, we just don't stop at control of the grid, at use of energy. We talk about a transformation. It really is a different way of thinking. The slide you see up there is what we view the old grid, a grid 1.0. It's very central generation, old style, long transmission lines, and then a wiring of distributed networks that connect the last mile of connection. A very old style. It served us well. It served us well for 100 years here in Canada, but we know that Grid 2.0 is a different way of thinking. And when you look at Grid 2.0, I mean, it's intelligent. It needs to know the state of where it is, how it is, where the congestion points are. It's efficient. It's moving supply as close to demand. I read a paper just the other day that talked about distributed energy and renewable energy, solar, battery storage, is coming to a point where it's at grid parity in terms of being able to cost, in terms of output. But when you combine the cost of moving energy, it becomes a lot more equitable and it becomes more popular, and it would become a choice, an option. So it will actually deconstruct these central power plants and long lines of transmission into more of a distributed architecture, moving the generation closer to the load. People talk about microgrids, and essentially that's what the world of electricity is going to be. And we're able to do that because we're an interconnected web of wires and lines. And this is where the complexity starts for people like us that are in this sector of moving electrons through our transportation system called the wires. We need to recover those costs, and to keep electricity affordable, we need to recover those costs over long periods of time. When investors come in, they like the returns, they like the steadyability, they will make the infrastructure investment, but not if there's a risk where we're abandoning infrastructure. So that's where regulations and policy tend to become a critical component of how you manage an electric system. We are lucky here in Ontario. We've had very good regulatory regime, and it's not without its complications, because the pressures from the public, our regulator represents our customer, and customer affordability is a top issue. Customer energy reliability is another top issue. And so our regulator has to be careful not to imbalance the balancing point between investors who invest in infrastructure, grid operators like ourselves who manage the points of reliability and affordability and availability to everyone to make sure it's available to everyone, as well as the consumer to make sure they're not paying too high a price at this moment of time, and really understand how they use energy and how lucky they are to be connected to something life-sustaining like energy. And so that's where communications comes in. When I think of some of our challenges, and I'll describe this slide in a moment in terms of the sensors that are available that manages the grid from source to load. And so we'll walk through some of the devices we have been successful in implementing. I know smart meters was the big thing that I think in Chile, they are really struggling with how to deploy smart meters in a way that does all the right things, signals to consumers how to use electricity and save money when they do, as well as let grid operators know where the congestion points are. But smart meters is the one starting point. For us, we did that in 2005, 6, 7. At that time, I was an executive at Toronto Hydro. We had the largest deployment of smart meters in North America at about 800,000 units. By far, the US now exceeds that. But at that time, it was the largest deployment ever in North America in terms of the use of smart meters. A lot of lessons learned in that exercise and how to deploy, but most importantly, how to communicate to the customer what it means to them. We were lucky to have a regulator and a government that wanted to push it, and they were supportive of it. So one message I will leave with the distribution industry is stay aligned with your regulator and your government to ensure they support the benefits and the value of a smart meter. Without that, it becomes difficult. The US is an example. Many people have been deploying pilot projects in smart meters without regulatory approval or without their government approval, and many projects have failed. Those who have been successful in lining up that direction, like us, were successful in their implementation. So let's talk about the different parts of the smart grid that we look at. But I'll leave you with this slide. The slides will be available. But the first thing we did is compare the traditional grid with all the characteristics and the value of a grid with the smart grid to focus on the differences and advantage. It's extremely important to talk about the value of smart grid. Many people look at it as bigger issues than it really is. It helps you manage the grid better. It's an investment for certain, and it's a big investment, but it is the future. It is the modernization of the grid. A lot of people look at it as, oh, we can still continue to build a traditional grid. Nothing's wrong with it. Nothing will fail. Nothing will cause concern with the way we did it before. And that's absolutely true. But like anything else, nobody argues the business case for internet these days. And look at the value. Nobody foresaw the internet as being the catalyst and an enabler for things like we're doing today, speaking internationally, remotely. So it's the things you don't know that smart grid enable, and there are many lessons there, but you take the first steps that make sense for you. So I always look at smart grid as the new standard, not an option. And it is part of modernization, not an option. Everybody likes to visit history and learn lessons from history. Nobody likes to stay there. So smart grid really is that evolution, and we call it Grid 2.0. Again, one of the things that we've had here in Canada, and today I would love to be in Santiago with you. I know your temperature there is about 20 degrees Celsius. Here this morning in Oshawa, it's about 1 degree Celsius. So we have snow here. It's part of Canada. And we recognize that our advancement of society depends on energy that underpins that advancement of the community. We've had an ice storm here, an incredible ice storm. Climate change is real and causing concerns. You don't need to look any further than the recent history of weather dynamics that have caused all kinds of problems. Here in Canada, British Columbia, a city in British Columbia, Abbotsford as an example, they've gone from record temperatures in June at over 104 degrees Fahrenheit, which is roughly 50 degrees Celsius. Never hit those points before. Record high swings in temperature this summer. Yesterday or a couple of days ago, they've had record rainfalls, which have washed away roads. So climate emergency, climate extremes are very real, and the grid is very susceptible to that. In our ice storm, we were able to use smart meters to quickly identify pocket areas that were out. So outage detection, outage information was a byproduct of smart meters that we saw was an advantage, but not necessarily to the extent that we used them during power restoration in an event of an outage emergency. Our old Grid 0.1 method was to drive up and down the streets or wait for people to call in. But when you have extended outages for 2, 3, 4 days because of weather and snow, nobody's home to make those calls. So smart grid was an important way for us to test out areas, A, that were out, and B, when we restored them, that we restored them fully. We didn't have to send somebody there to inspect and make sure that the lights did come on. So that's an example of a very good dynamic of what smart meters did for us as one of the evolutionary parts of smart grid. When you look at automation in the next slide, we'll talk about how smart grid basically started to evolve the communications network, where these devices begin to interoperate with each other and speak to each other. And so this slide, you'll see the old meter, and I talked to you about the expense of installing the new meter. The old meter was roughly about $35 here in Canada, 35 Canadian dollars. And as a great marvel of engineering, I often tell my engineering classmates when I'm teaching in school that the electromechanical meter was one of the most fantastic devices, very well-built machine that is truly a marvel of engineering design, and it worked very well. However, the new smart meter, much smaller. In fact, we made it fit the footprint. It could be fit into a much smaller dynamic. And when we deal with newer environments like condominiums, where we can now meter each individual unit, they fit in a much smaller footprint than the old meter. But we made the first version of the smart meter fit the old version of the meter socket, and they were roughly about $100. Now, for same $100 is escalated functionality in the smart meter, but we knew that all along. So we had to make the business case that we would pay 3 times more for a smart meter and had that much more value than we did for the old electromechanical meter. That's why we started with smart meters first. The real critical element, and I'll talk about that, and I mentioned it as regulatory and politics, the real value of the smart meter was to start to signal to consumers the cost of electricity in peak times. Here in Oshawa, we've done pilot projects related to critical peak pricing to determine whether consumers will switch their behaviors and at what point do you need to have the ratio for on-peak versus off-peak. In our particular study, it showed that that ratio should be exceeding 3 to 1, and it should be closer to 5 to 1. So the price of peak should be 5 times more expensive than the price of non-peaks in order to send the right signals to consumers to ensure that they use energy as efficiently as possible. Having said that, in Ontario, we still have subsidized rates because of the energy affordability issue, and that's the politics behind the energy file. The governments realize people are not yet ready to make that kind of switch. And so today we have price points that are roughly in a ratio of 3 to 1, but they're heavily subsidized by the government to make them more affordable. So again, the whole notion of moving to the next generation grid and the newer standard that I define, there's no looking back going to the old standard, is to look at interoperability and to look at the dynamics as you get to software applications, to learn as much as possible and to how to manage the grid to be more efficient and more affordable for our consumers. Here's an example of one of our power bills, and what you're seeing on your screen is the on-peak, off-peak, and mid-peak pricing. So green is the off-peak, yellow is the mid-peak, and red is the peak pricing points. And we have a summer and a winter type pricing schedule. And obviously on weekends, it's all off-peak and statutory holidays. Underneath that diagram is where we show how the devices communicate through a local area network. And again, communications, this was our lesson. Communications in a smart grid, owning and operating that is critically important for utilities. The conduits to get that information are things you have to manage when you look at things like cybersecurity and the security of that information. It's critically important. And because of that, and because of the critical aspect of communications with operating a grid and controlling that communication side of the grid, again, another network, we're now able to offer that as internet services to our community as part of another utility. So that was one of the pushes behind getting into communications. And if you look on the far left, this is a regular bill in the city of Oshawa for the month of February for roughly about 30 days of consumption, about $120. I'm not sure if that's really expensive for your community. That includes, and you'll see the components that are part of the bill, that includes the price of generation, the price of transmission are tariffed separately, the price of distribution, that's called a delivery charge, is tariffed separately, that's my charge. And then when you look at other aspects, like we have a regulatory charge, the cost of putting a market in place using the regulator is also one of those charges that form the total complete charge of about $120. So my cost as part of that bill is roughly about 30%, 25% at about $40 on the 120. So that gives you a little bit of background about the smart meter and the billing and how it fits with part of regulations, and how we manage to ensure that we're sending the right price signals, maintaining affordability, and that was what enabled the next parts of our grid. What you're seeing here is we've put these devices, power line monitors, which are now at a scale of quality that can give you all the parameters along the line, and most importantly, fault detection. So smart meters and that technology and the Internet of Things evolved into all the other applications of our grid, where it became economically affordable to start transitioning our grid 1.0 to grid 2.0. we've started putting these devices as our next piece of the transformation. We did a lot of this work in 2010, 11, and 12, where we were getting what we call almost relay compatible information on different parts of our grid that were very effective, very cost effective for us to look at constraints on the grid, map out that information, communicate back to our source breaker controls. And what we like again about that grid transition was a lot of the internet components that are available out there started to be developed for our particular application and really affordable. The way I really describe it is it's the application of that technology, not the invention of the technology, that allowed us to scale our devices and modernize our grid. The next area we evolved into was smart switches. Again, the speed, the scale, and the type of switches we were able to afford at the distribution level allowed us to automate the grid, and the interoperability of these devices with up and downstream devices allowed us to basically manage our grid to where in Oshawa today, we used to have, we measure grid outages in frequency and duration. We used to average roughly 1 to 2 outages on average per customer a year. This year, we are down below a half of an outage per year. So we will give on average a customer an outage every 2 years. And we have not begun to deploy all these devices. Our strategy with switches is we had one at the endpoint, we have a breaker at the front end of that device, and we've deployed a switch at the midpoint. And we've done that on our feeders. What we wanted to do is at least get to a stage where we call it 4.5 automated points on every particular feeder. A feeder roughly has 2,000 customers attached to it. And basically we wanted to at least put three additional automation points on that feeder. One of the other devices we did was we installed smart meters in and retrofit them into the existing pole mounted transformers, where again, we can now begin to get integration between the point meters at every home and the source point, which is a transformer. And it helped us a great deal to basically identify theft of power, or diversion of power, or unmanaged power. It also helped us identify overloaded situations. Mostly transformers are run to fail. And so the cost of these devices have allowed us to manage the grid and our assets at a point in time where we're now predicting end of life before it happens in a much more accurate setting. So again, the smart meter, it's basically embedded in a transformer as a combined unit that now gives us information on a particular asset in addition to the consumption at the home. Once we started looking at these point data, so these are all data elements that exist out in the system, they then need to communicate back to a way where applications reside that begins to run in the background. And again, when I look at the tools we're using around spatial planning, the GIS system, the customer information system, CIS, the SCADA system, the controls, and the AMI, which is a smart meter head-end systems. Those have to form together. In our particular case, we brought in those 4 systems and layered on an outage management system, an OMS on top of that. So now we begin to get intelligence beyond the data. So we're using data points. We've combined 2 data points for information. And lastly, we bring that information into a scenario or situation where an application now manages the decision points out of those systems. The examples I'm showing you in our particular service territory, if you look on the far left, that's a heat map of overloaded components on our grid. So we managed to take that data, combine it into a spatial plan that identified critical peaking, critical overloaded components in our grid, things we couldn't have done years ago without a lot of manual effort. So again, started with smart meters, backed its way into the grid, now worked its way into applications. The other diagram in the middle that you see there in yellow, the next spatial plot, is where we look at our history of how load is flowing through the city. It's not, we use it as a dynamic, and it color codes from yellow to green to red for different periods of the day. So now we've basically pulled in time-stamped information and run an application that identifies when and where during times of the day, times of the week, times of the month, times of the year, load begins to move in and out through our system. And last but not least, on the far right, where you see those red pins on a diagram, that's our outage, our equipment failure database pinned to an outage map to show clustered problems or clustered issues on our grid. This is still reacting to what's going on the grid. We'll talk a little bit about what's coming down the line with future parts of the grid, and a lot of this information can help on the planning side of that grid. One of the things we did immediately with smart meters is start producing outage information, and I'm showing you our outage map that we communicate online in real time to our customers. Most utilities here do it. Smart meters enabled it. Our customers really are satisfied that they no longer have to call you. And you can imagine thousands of people trying to call your call center to let you know of a problem when you already know of the problem. And what we do is communicate that out to prevent that call. Customers are happy because they know you know about it, and it prevents them from having to stand in a lineup to tell you about it. B, what it begins to say is how big it is, whether it's something that's going to be a half an hour or 2 hours or 3 hours worth of time because of the size and extent. And then lastly, it's something our customers expect. They want to know from the utility, you know about it, you're doing something about it, and then tell me what's going to happen that makes sure it doesn't happen again. So pretty much if you go to any utility website now here in Ontario, you'll see some form of an outage management, and it's how we now begin to communicate with our customers. So smart meters communicates with us. We now begin to communicate back to the customer. So this is an example how we've advanced our grid to the point where we are now communicating what's valuable to our customers. I talked to you about sending price signals and critical peak pricing. That blue button in Ontario now, where we are now going to the green button standard. It started in the US, it's found its way into Ontario. But prior to that, we created the blue button. And I told you earlier about a study we did around critical peak pricing. We developed it with an international company called Sapient around studying the price elasticity of energy for consumers at their home level. So now we are communicating with the customer. When is it more affordable or less affordable to use more or less energy? And we've done it through what we call the blue button standard for our study. It's now the green button standard. And now we're letting customers know you can control your thermostat. You can control the use of your appliances. You can control all your lifestyle choices by an affordability signal. And when we give them that signal, then it becomes their choice. It was a very empowering study, all underpinned with the smart meter. And so our customers now expect us to let them know where they can A, save money, and B, when they're becoming less or more efficient in the use of their electricity. One of the other projects we did was a microgrid at the home level. We work with Tabutsu of Japan. And what I'm trying to give you, we're a small company in Ontario, but we've worked with international players because that's the kind of company we are. I'm trying to give you a flavor for you don't have to be a large company to do these kinds of projects. We work with Tabutsu Electric out of Japan. We've worked with a local player that helped develop some software. It's out of Montreal that basically put a battery solar microgrid in a home and managed and controlled that home on and off grid. We did 30 homes in the city of Oshawa, and this was to prove the grid parity and the cost effectiveness of putting these solutions into our grid. So if you can imagine, we're incenting and doing a study that allows customers to not connect to our grid when it suits them. And this study was fantastic and successful results. Unfortunately, with the subsidized price of hydro from the government or the utility, the price of energy from the government to the customers, it doesn't make the economics pan out immediately. So in other words, until the price of electricity climbs higher, these solutions will not be affordable for consumers at the moment. But it is reaching the point, and this study helped us identify those price points for which that would be a market that we would eventually lead down the path and help customers. So I talked about Grid 1.0 and Grid 2.0 as being smart grid, but there are actually 3 smart grids. I was mentioning to you around the use of data that smart meters provided and other devices, combining them to give you information, eventually using that information to make decisions or knowledge, and then eventually wisdom starts to play in when those decision points are automated. And so we see this as Grid 3.0 is when you finally get to the application level of your grid where things are running in an automated way that is in real time dynamically changing the status of the grid and the use of the grid. We will really move down what we call the data continuum here in Ontario. One of the luxuries I've had in the past was representing Canada at the IEC, the International Electrotechnical Commission, in developing smart grid standards. SG3 was the group I was working on. And one of the nice things we did out of that group early on, which helped me understand the value of a smart grid, was looking at the architecture, the data architecture. So I talked about data, using data to inform decisions. But what was really critical to really understand how powerful these solutions are is to look at the data architecture to see how in implementing these systems and integrating these systems, you need to have the standard architecture for interoperability. That is a key component. Standards are a key component, and we are there. These standards have been developed, and these standards are available, and the suppliers, the international suppliers, Siemens, Schneider, ABB, they were all at the table agreeing to these interoperability standards and helping to set the framework for people like us at the utility level that can call for these standards when we look for these smart grid devices in our next generation grid deployment. So I talked about our generation company. We own natural gas combined heat and power, very efficient to do heat and energy development in at least in Canada. Solar power, biogas. We have a biogas facility. And we have windmills. And last but not least, I'm showing you a picture on the far right around our district energy system in the largest cooperative residential community in North America, Toronto Community Housing in Regent Park, Toronto. So while I'm in Oshawa, we do work in one of our companies, Enerforge, in downtown Toronto. Now, looking ahead, you look at things like electric vehicles. Electric vehicles is a very complex device. It's a load as well as a resource, and it moves in the system. We have people visiting the city. We have people living in the city, visiting other cities. When we look at electric vehicles and the value of smart meters, you can now register your smart meter and your device as an internet connected device onto a system anywhere in Ontario, so that when you plug in somewhere else, you can send the bill to your home on your meter. So now you're this registered internet device that can move around in our grid and connect anywhere to send your information on your electron consumption or your electron interchange. It's a two-way grid now. So again, smart meters is a gateway to that next piece in the planning cycle in preparation for these devices, which you know as well as I know, COP26 is pushing a greener agenda. Canada is committed to it, and we are definitely working down this path. Transportation is the biggest emitter in Ontario today, and so we're pushing hard on the conversion of our fleet from internal combustion engines to electric vehicles. Standards is one of those things, again, that is plaguing that industry. One of the things we've deployed electric vehicle charges in our network that we own. But the problem is there are 4 different charging standards. With 230 available models of electric vehicles deploying one of these 4 standards, it becomes awful difficult to have a universal plug. So one of the things we have to do a better job of is working with the people who develop these devices and make these devices that have to interface with our grid, both data and energy, and develop a universal standard. 4 is not that bad, but it's still probably 3 too many. It would be great to have 1 so that a universal charger exists for every device. And then last but not least, these are all the other technological pieces that are down the path of planning ahead into the future to ensure that we're prepared. One of the things we complain about in this sector, and I'm not the one complaining, but I hear my other CEO counterparts complaining, is that the grid is not ready to accept these large loads called electric vehicles. I mean, a 160 kilowatt hour battery connecting to the grid is almost, if not as big as a house, much bigger than a house, depending on the demand that it draws from the grid. And so, you know, utilities are still thinking in the old planning model where they're thinking they have to plan for 100% connectivity all the time. And developing a grid at that kind of planning methodology means that you're going to invest billions of dollars, because those are the numbers quoted, and you're going to strand those investments. They might be used for an hour of the day or 2 hours of the day. That's ineffective investment. Where smart grid begins to enable the decision and the planning for this is to begin to incent people when to connect, when not to connect, where you have capacity, where you have constraints. And so you can begin to manage and control the impact of how people interface with your grid without investing billions of dollars in making it a plug and play anytime, as much as you want consumption, which is ineffective for something that's a mobile load and a temporary load like electric equipment, vehicles and transport and such. But we are looking forward to these devices coming to the grid down the road and looking forward to looking at how Smart Grid 2.0 develops. And with that, I'm going to leave that with you. I've put a lot on your plate, and hopefully there's something there that captures your interest and you'd like to start a dialogue, because from my perspective, sharing is critically important to advance our grid because it's an interconnected grid. What I tell my students when I teach, I say, the electric grid is the largest machine, the largest assembled machine in the world. When you look at North America, we're an interconnected North American grid. Most of the eastern part of Canada and the northeastern part of the US is one interconnected grid. And so, you know, I'm very proud to say I play in an industry that forms part of the largest machine in the world. And Grid 2.0 or Smart Grid 3 is going to be our challenge and our opportunity for all of us to build it together. So I will leave it at that. And hopefully I didn't go too quick and I didn't upset the translator out there. And I'm happy to take any questions.
Muchas gracias, Ivano. Excelente.
Thank you very much, Ivanov. Excellent presentation. Actually, it's very clear. Thank you very much for all your experience. We can tell you know a lot about this topic. We have questions by the audience. One question is by Alberto Chevent. The question is, what are the lessons learned regarding the ownership and the management of the information of the customers?
Okay, that's Alberto's question, right?
Sí.
Yes.
Here's the lessons in smart meter. There's tons of information that was exchanged. We knew information was going to be key, and we worked very closely with the provincial privacy officer. So privacy standards were developed in concert with smart grid and smart meter deployment. The privacy regulations were very simple, but they were very important to convince consumers that we were not going to use the information against them. So it was more of a confidence builder than it was a smart regulation.
Mm-hmm. Sí.
And sorry, one other element. We also said the customer owns the information. So while we hold the information, we cannot give it away without the customer's consent.
Yeah. Okay. Tenemos otra
We've
pregunta.
got another question by Francisco Martinez. He's asking about, his question is the following. He assumes Chile has better solar radiation for generation than Canada. In your opinion, which are pros and cons of the DCO for the higher penetration of distributed generation, but of batteries storage as part of the solution? He thinks the penetration of batteries will be front of the meter or behind of the meters.
Catherine, correct?
Yes.
That's an
Yes.
excellent question, Francisco. I think let's start with the last question first and then work backwards. Battery storage is going to be both in front and behind. And the example in front is for electric vehicle chargers. When we have electric vehicle chargers that are type 2 and type 3, we are knowing that we are going to have a buffer between the load and the grid. And so battery storage with electric vehicle chargers in front of the grid is essential for that kind of combination. In our battery solar energy storage project, we found it essential to have the battery behind the meter in front of the solar panel, and obviously that worked well for the customer. That diagram I showed you in our particular example was a 10 kilowatt hour battery storage and solar system. And it was the good news of the Tabuchi solution is it was a very small footprint that fit in the basement of a home. And it was basically that 10 kilowatt hour storage was the smallest footprint with the highest density on the market at that time. It was roughly a 3/4 meter square cube. When I look at the other parts of your question, it's funny that people look at the South as being the most economical place for solar energy because it's warm, obviously. But in Canada, and especially in the far north, we have some great business cases for solar generation. And solar alone in Ontario is at grid parity. So it will pay out in roughly a 10-year time frame. The problem here for safety reasons is the solar panels are turned off at the inverter to prevent backfeed into the grid when the grid is down. So customers are disappointed that during an outage, they cannot generate. So there are many rooftop solar systems in Ontario, but it's impossible to have a roof that fits the size of the load so that they can go completely off grid. So the existing rooftops do a part of the home, And then if you don't have battery for nighttime, you can't generate at night. So batteries are going to be critical for solar systems here. Thank you for that question.
Muchas gracias, Ivano.
Muchas
Thank you,
gracias.
Ivano.
Excelente presentación.
Excellent presentation. Thank you very much. Now we are going to move on to the next block. Thank you very much for your participation.